Hi, my name is Takuzo Ganre. I'm a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same, or if not, just to make A-level maths a little less challenging for you. So in this video, we'll be solving questions on finding the equation of a straight line. So number 1, points A and B have coordinates 5, 2 and 10, -1 respectively. Find the equation of the perpendicular bisector of AB. So we have the coordinates of A being 5, 2 and the coordinates of B being 10, -1. So let's sketch a diagram to see what's going on. So we'd have A being somewhere here and B being somewhere here. And if we join the two dots, we get our line AB. And so we want to find the equation of the perpendicular bisector. So the perpendicular bisector will split this line in half and it intersects at the midpoint. So this is the bisector, perpendicular bisector, and it intersects the line AB at the midpoint, and it's perpendicular to the line AB. So to find the equation of a line, we either need 2 points or we need 1 point as well as the gradient. So in this case, it's easier to find the coordinates of the midpoint as well as the gradient of the perpendicular bisector. So to find the gradient of the perpendicular bisector, we'll use the idea that perpendicular lines, the product of the gradients of perpendicular lines is equal to -1. So if we can find the gradient of AB, we can find the gradient of the perpendicular bisector. So the gradient of AB is equal to -1, -2 divided by 10 minus 5. And so our gradient would be -3 over 5. And now we can use m1 times m2 equals -1 to find the gradient of the perpendicular bisector. So that would be -3 over 5 times m2 is equal to -1. So m2 is equal to 5 over 3. So this is the gradient of the perpendicular bisector. Now we also need to find the midpoint of the line AB. So that's m is equal to x1 plus x2, that's 5 plus 10 over 2, comma y1 plus y2, that's 2 minus 1 over 2. So the coordinates of the midpoint are 15 over 2 and 1 over 2. So now that we have a point that lies on the perpendicular bisector as well as its gradient, we can find the equation of the perpendicular bisector. So y equals mx plus c, and in this case our m is 5 over 3 and the point is m 15 over 2 and half. So we'll come and substitute y with 15 over 2 and m is 5 over 3, x is 1 over 2 plus c. 15 over 2 is equal to, this is 5 over 6 plus c, so c is equal to 20 over 3. So that means that the equation of our perpendicular bisector is equal to y equals, our gradient is 5 over 3, x, and our y-intercept is 20 over 3. So it's y equals 5 over 3x plus 20 over 3. That would be our final answer. Now let's move on to question number 2. The coordinates of points A, B, C are A 5, 2, B 10, 3, and C 2P, P, where P is a constant. Given that AC is equal to BC in length, find the value of the fraction P. So let's start by finding the length of AC, we'll use the formula length is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So in this case, AC is equal to, that's 5 minus 2p squared plus y1 being minus 2 minus p squared. And then we also need BC. We'll use the same formula since it's also length. B is 10 minus 2p squared plus 3 minus p squared. Okay, we're told that AC is equal to BC, so we can equate the two, and that's root 5 minus 2p squared plus negative 2 negative p squared is equal to the square root of 10 minus 2p squared plus 3 minus p squared. So we can square both sides to get rid of the square root sign, and it would become 5 minus 2p squared plus negative 2 negative p squared is equal to 10 minus 2p squared plus 3 minus p squared. Now let's expand these brackets. So the first one would result in 4p squared minus 20p plus 25. The second one would be p squared plus 4p plus 4. And now the right hand side, that's 4p squared minus 40p plus 100. And the last one is p squared minus 6p plus 9. So let's group like terms on either side. 4p squared plus p squared gives us 5p squared minus 20p plus 4p minus 16p. 25 plus 4, that's plus 29. Now on the right hand side, 4p squared plus p squared, that's 5p squared minus 40p minus 6p minus 46p. 100 plus 9, that's 109. Now let's put all the terms on one side. So that's 5p squared. We'll move this 5p squared to the left, it becomes minus 5p squared minus 16p. We'll move minus 46p to the left hand side, it becomes plus 46p plus 29. We'll move the 109 to the left hand side, it becomes minus 109 is equal to 0. Now the 5p squares cancel out, then we have minus 16p plus 46p, which gives us 30p. Then we have 29 minus 109, which is minus 80, is equal to 0. And now let's make p the subject of the formula. Divide both sides by 30, and you get p is equal to 8 over 3, and that is the final answer. Now let's move on to question number 3. Points A and B have coordinates 8, 3 and PQ respectively. The equation of the perpendicular bisector of AB is y is equal to minus 2x plus 4. Find the values of P and Q. So we're given that the coordinates of A are 8, 3 and the coordinates of B are PQ, and we're also given the equation of the perpendicular bisector of AB, which are y is equal to negative 2x plus 4. So if we were to sketch a diagram just to picture what's going on. We'd have A being somewhere here and B possibly somewhere here, and if we join this line it would look like this. Then the perpendicular bisector will come and cut this line AB at a 90-degree angle, and it will make sure that both sides are equal. Since it's bisecting, it splits the line equally. So this point that it cuts it is the midpoint. Okay, so since we have the gradient of the perpendicular bisector, we can find the gradient of the line AB. These two lines are perpendicular, so m1 times m2 is equal to -1. So in this case, -2 times m2 is equal to -1. This means that m2 is equal to half. So the gradient of AB is equal to 1/2. And if we were to substitute the coordinates of A and B into the formula for gradient, it would look something like this. That's 3 minus q over 8 minus p is equal to 1/2. So we can also create another equation in terms of p and q using the midpoint. So the formula for midpoint is m is equal to x1 plus x2 over 2 comma y1 plus y2 over 2. So the coordinates will start with a, that's 8 plus p over 2, and 3 plus q over 2. So from our diagram here, we can tell that our midpoint m lies on the equation of the perpendicular bisector. So since we have the coordinates of m in terms of p and q, we can actually substitute them into the equation of the perpendicular bisector, and we will get an equation in terms of p and q. So our equation of the perpendicular bisector is y equals -2x plus 4. We can substitute x with 8 plus p over 2 and y with 3 plus q over 2. So it would become 3 plus q over 2, that's y, is equal to -2 times 8 plus p over 2 plus 4. And now we can simplify this. 3 plus q over 2 is equal to, these two will cancel out, that becomes -8, don't forget this negative sign, -p plus 4, so that's 3 plus q over 2 is equal to -4 -p. Let's multiply both sides by 2 to get rid of the denominator, so that's 3 plus q is equal to -8 -2p. Now we also have another equation in terms of p and q. That's 3 minus q over 8 minus p is equal to half. So let's also make it linear so that it's easier to see. So in this case we'll cross multiply. So that's 2 times 3 minus q is equal to 8 minus p. So this becomes 6 minus 2q is equal to 8 minus p. Now we can solve these two equations simultaneously. So let's make q the subject of the formula in this equation. So it becomes 3 minus 3 minus 8 minus 2p. Q is equal to -11 minus 2p. Let's substitute q with -11 minus 2p in this equation. So it becomes 6 minus 2 minus 11 minus 2p is equal to 8 minus p, and this becomes 6 plus 22 plus 4p is equal to 8 minus p, which is 28 plus 4p is equal to 8 minus p. And let's move the -p to the left hand side, so it becomes plus p is equal to 8 minus 28, and this becomes 5p is equal to minus 20. Divide both sides by 5 and you get p is equal to negative 4. Now let's go back to this equation to evaluate q. So q is equal to negative 11, negative 2, substitute p with negative 4, get q is equal to negative 11 plus 8, q is equal to negative 3, and this would be our final answer. So that's it for today's video. Thank you for watching.